Hi, folks. Thank you so much for joining. I know that you're here, like, giving up time with your families, giving up time that you could be managing your inbox, which for me is a chore and also something that I still need to work on. But we get how much it takes from you to be here, and we really appreciate it. I want to acknowledge that we are on native land, including Massachusetts, Nipmuc, Mashpee, and Wampanoag. And my name is Merritt Bear. I am in AWS Security in the Office of the CISO, the Chief Information Security Officer. We're really excited to talk to you today. We have a lot of interesting stuff to share, and a lot of it is stuff that we have not said out loud before. So that's really exciting. Paul, can you do an intro, please?
Yeah, sure. So I'm part of an organization in AWS that builds services, and particularly the ones that protect the perimeter of your applications. And so these include Shield, WAF, Network Firewall, Firewall Manager, etc. And specifically, I'm on the Shield team. I look after the Shield response team, Shield advanced customers, and also we protect, obviously, ourselves from DDoS. So that's how I fit in here.
Yeah, awesome. Shouldn't have set that down. No, clicker. Yeah, we may have to manually advance. Okay. Is it going?
There we go.
All right. Nope. One more. So the title of this talk refers to layer 7, right? And we just want to make sure that we're level setting when we talk about layers. When we are talking about layers, we're referring to the OSI layers of the stack. So the same way that your cloud provider is basically the business proposition that we are taking care of everything from the guards and gates and concrete floor up through layer 4, the hypervisor. We are talking today about layer 7, or the application layer, which should be super relevant for everyone who's trying to do anything because it involves the internet. And as we know, this is a challenge because, as we will get into, the internet is a complicated, messy place. But in a lot of ways, this is one of the conversations that I think is most important to have. And again, we'll get into this a little more. All right, so I hope you enjoy our childhood pictures. This is us kind of developing into the people that we are today that care about this from each of our angles, right? I, as I mentioned, am in the Office of the CISO, so I sit in AWS Security. We are a security shop that runs on AWS. It will probably not surprise you to learn, although kind of interesting to think about how we leverage our own services and our own threat intel, and then are able to translate that out to customers. I work on everything from employee guardrailing to threat intel. And then I work with customers and CISOs directly. If a customer says, my CISO wants to talk to your CISO, they usually get me. And on the third bucket is the product side. So this is where Paul lives in the service team, although he also helps with AWS security, as I mentioned. But ensuring that everything we deliver, not just security services, are built with a recognition and an observable kind of best practices to current security standards.
Yeah, excellent. So on my side, I think it's a bit of a selfish motive about why you should be here and why you should care. And that's because we actually do a hell of a lot of work on your behalf to protect the availability of your applications. And so what I want to make sure that you walk away from today is a great understanding of what we do for you, how we do it, so that when you walk away, you're confident in our ability to protect your availability, and highlight some of the sort of great stuff that is happening behind the scenes that you may not be aware about.
Yeah, Paul's team is working on stuff that allows you to not worry about it. In the sense, it's the stuff that you feel but don't touch or see because it's on our side. And then we're going to get a little bit into what you can do on your side at the end in terms of leveraging those which run on top of what Paul has built and being able to architect for high availability and for, protection against layer 7 threats yourself.
All right, so this may be a revelation to you or it may not. Depends if you're in the security field or not, but the internet is not always a happy place. I'm sorry if that's the first time you're hearing it, but it is absolutely not always happy. There are areas of it that are dark and dingy and dirty, and we as AWS see a lot of this. We do a good job of protecting you from it, even though you may not know it. And so if you are intentionally trying to avoid it, trying to not cross paths with the grungy internet, someday you need to. That's a reality. And someday you're going to have to know what to do when that day comes. And so what I want to do now is explore a bit of what we're seeing from AWS perspective in the internet grunginess. Thanks.
This is working now.
Is it working? Great.
Yep.
All right. So DDoS, distributed denial of service, is by far the most grunge that we see frequently. It's, if you're not familiar with it, a targeted attack to affect the availability of your endpoints. And we see here sophisticated request flows. So we're talking about layer 7, remember? At layer 7, request flows look very similar to legitimate traffic. And so it makes it that even more complex to defend against and trickier to protect your instances. And so, when it's not availability, we're talking about exploits. And here, you see this all over the internet. People trying to take advantage of the vulnerabilities or the issues that are on your application stack. And so maybe it's that you haven't patched your software, or maybe it's been written by a manager and it's just poor code. I can say that because I'm one of those managers.
Oh, burn.
Okay. But regardless of what it is, you need to protect against these. And so you'd be familiar with the OWASP top 10 and CVEs, or common vulnerabilities and exposures, that are running rampant at layer 7. Of course, bots and scanners are very common across the internet, right? There's running enumeration attacks across the whole internet space, including AWS. And here they're trying to, steal, or not steal, but scrape traffic or content off your websites, or try and understand your architecture. And this is ongoing day and day, and we have to protect you against this. So before we get started with what we actually see, and I'll show you some data, the key to start off with is that we actually listen to this. Now, I don't know if that surprises you or not, but we're a big provider of AWS service, of web services. And so we hear a lot. We listen to the noise coming from the internet because it provides us a unique perspective on what grunginess is happening out there. And so how do we do this? How do we listen to the internet? How can you listen to the internet? The way we do it is we run a network of sensors. These sensors are running on tens of thousands of IP addresses daily and distributed across the 20+ regions that we've got today. And there are listening to around 30 to 40 million interactions per day. That is a ridiculous amount of grunge, all right? We hear this, and we're going to go into more detail about this later, but what this helps us do is proactively understand what is happening out there so that we can build defense mechanisms and protections, features and services that help you guys. All right, so I want to start by looking at some of the DDoS trends and metrics we've seen, especially starting with this figure.
As I mentioned, these are new. I mean, we have not released these, so these should be interesting.
Let's hope they're interesting. 438,000 DDoS events that we've seen in the first half of this year. This is, if you just apply some simple calculus and algebra, you will work out that it's about 880,000 events that we're expecting this year, which is around 100 DDoS events in an hour, right? You can't do that manually. You can't protect a scalable network with such reach manually. So we build a lot of software and defense mechanisms to protect AWS. We protect ourselves, of course, as well as you through this. And there's no signs of this slowing down. As I pointed out there, 30% up from the same period last year. That's crazy. Our research has shown that this has been driven by the use of proxies. Proxies are being exploited, open and private proxies being exploited, as well as the growth in botnets, which we'll touch on later. This figure we can look at in two categories, right? You may be familiar with this, but infrastructure layer events are the kind of SYN flood, UDP reflection ones, the ones that happen at the lower, the layers down at the bottom of that cake that we looked at earlier. So I know we're talking about layer 7, but it's important for you to understand this, that is happening at all over the place. And they're automatically detected and mitigated by our systems that monitor traffic coming in from our border. Web application layer events. These are detected events that are statistically different to traffic that we baseline for Shield Advanced customers, right? So if you're running Shield Advanced on CloudFront or Application Load Balancer, we have an idea of what a baseline looks like. And these events that we see here are different in the composition, maybe in the volume, or the composition where we're looking at different dimensions like user agents or URIs, etc. And these events, the layer 7 events, contributed 35%, right? 35%. Now, that's not the majority, but it is growing quickly. If we look back over the 12 months, there is a 47% growth month over month in the number of application layer events that we're seeing. This is much higher than the infrastructure layer growth, which is 27%. You might be sitting there thinking DDoS is old news, but in actual fact, it's on the up. We continue to see this increase and the sophistication of these attacks is growing quite considerably. So, of course, not all events are equal. So let's take a look at what this looks like from a size perspective, all right? We see a lot, as I've just been saying. And here, you can see that P95 up there on the side. That is the percentile, right? If you're not familiar with percentiles, this is the value that 95% of all web application layer floods we see are below, right? So 95% of web application or HTTP floods are below 147,000 requests per second, which doesn't seem super high. Obviously, you've heard about higher in the news, but these are deceptively impactful, especially if you haven't taken advantage or architected your application in a way that can scale and use AWS native scaling tactics. Now, of course, we do see higher than this. And so the P99 is almost 3 times more what we're seeing here, right? So this is just a short little slice more than the P95, but it's 3 times the volume, all right? Again, 415,000 requests per second, which we can defend against with the services that we provide, right? Those specifically are Shield and WAF. And if you're taking advantage of edge services, you're even better protected from the scale of these attacks. Now, I don't know what, you obviously are sitting there with a figure in your mind going, our application sees this type of request per second. And so you might be going, that is a flippin' big number. Or you might be thinking, that's pretty small. We do see higher than this.
It is a big number.
We do see higher than this, of course. So our maximum this year has been 4 million requests per second. I mean, that's ridiculous. Imagine that attack continues for 5 minutes or 20 minutes or 2 hours. You've got that rate of traffic coming in. You've got to be prepared for that. And so, as I mentioned, we've got services to help you with that, but this is outstanding, and we're going to go into a bit more detail later, but this is where those proxies come into play. People leveraging open proxies and private proxies to reach this sort of distribution.
And just to be clear, we're taking these.
Yeah, 100%. So what about non-availability risks, right? So this is a look at 90 days back, just from CloudFront's perspective, right? If you're not familiar with CloudFront, it's our CDN. And these are, this blue line at the top here is 30 million requests per day matching well-known threat signatures. I mean, that is cross-site scripting attempts. Just going on day after day after day. SQL injection, and the bottom one is the zero-day threat signatures that our research team, our threat research team has put together based on what we've observed, over the past, moons that have gone on. The point I want you to walk away with, it's not a really attractive graph, but the point is this stuff is going on day after day after day. It's crazy. It's just really grungy out there. And then I know this is not strictly layer 7, but it's a pretty cool story because these, spoof traffic, everyone knows what spoof traffic is, right? Someone pretending to be somebody else, sending you traffic. It's a great vector for DDoS. In this case, traffic is being sent to our network and someone going, hey, I'm coming from an AWS source IP. I mean, like, come on, buddy. We know, we are AWS. Stop sending us traffic and pretending to be us. So this is just one region from traffic coming from our transit providers that is pretending to be Amazon. The percentages are small, but if the volume that we spoke about earlier, it can be quite a lot. But it's just another idea or another picture of what we're dealing with day after day. So there is a little bit of grunge out there for everyone. Pick your flavor. It's up to you. We do a great job of trying to defend you from this so that you can just keep it cool and eat a popsicle. But there's more in it for you today, right? So did I just go 2 slides?
Yeah, I think yep.
Go ahead.
It's all good.
Merritt's just going to take us through what's
I'm back, yeah. So we've done a little bit of a broad overview here on what we see. And as I mentioned, these are really cool. It's one of the things that we gather on our side to be able to give intelligence to the products that we deliver for you. I'm going to just take the next segment and walk through a little bit of kind of the alchemy and composition of what a denial of service attack entails. Let's start with the fact that it's money motivated, right? So this is not an act of God. It's not the hurricane or the earthquake. Like, this is some bad actor who has decided that they want to make money. And that matters because as you're thinking about defending against these, you need to think about what their motivations are and what their capabilities are. And so we want to walk through a little bit of what these come in the flavors of, popsicles per se. But the 2 main distributed denial of attack flavors are in botnets and proxies, and I'm going to get into those a little. I will give the caveat that I do know that there are other denial of service attacks out there, things like a slow LoRa's, which actually, impedes you because it opens up a maximum number of ports and keeps them open. Like, not every DOS is a DDoS, but I'm going to talk about DDoS today because these are the main flavor of volumetric attacks, of attacks are volumetric. And because volumetric attacks are something that we're uniquely positioned to see, being as we are your vantage point for seeing the rest of the folks who are impacted. All right, so let's go back to the beginning. There is a bad actor who wants to do something, right? So the idea here is just that, there are some attacks where one bad actor with his computer can enact something against you, but those are not the talks that we are talking about today. And for the type of attack that we're talking about, volume matters. So you want to scale the attack. Maybe you go to your local library. Good luck, right? But ultimately, you're going to want to get a little bit more aggressive. This is a picture of a command and control center in, I don't know, the universe. Because the idea here is that at some point you get to the stage where they are actually enacting what we would now call a botnet. So we're getting to the point where you can build a botnet and you're actually taking, what would otherwise be innocent devices or like neutral, ordinary devices and turning them into something that's under your control. And the reality here is that it's going to be software driven, right? So, and this is malware because that's malicious software, and they will get a hold and then give out a call. The devices will then say like, yes, I'm ready. Tell me what to do. it should be no surprise that, like, as with the rest of the internet, sometimes they try to build them on AWS and other cloud services. This is a reflection of misconfigured customer instances, because these guys are not, and they are usually guys, are not building them, by opening an account and paying for it. So keep in mind that this is something that we can all help to clean up if we ameliorate our configurations. That's kind of a topic for another day. That could be a whole talk track unto itself, but keep in mind that that's how this is happening. That being said, compared to an on-prem or just a standalone machine, like, we're watching everything, as Paul said. There's a lot of beauty in the fact that we do have automated remediations. We have ways that we can identify and then create fact sets around ways. I think my hair is hitting my microphone, sorry. That we can create ways that we identify and then minimize the ways that they can impact folks. But keep in mind that this is one of the things that we care about. And like, bad actors love web services for the same reason you do, right? They're elastic, they are dynamic, they are scalable. And so this is no surprise, but what I think folks may not realize is that actually puts them in our backyard. And we like backyards because we can watch what happens. And I don't think you realize that we are like watching this, that we are calculating, that we are building signatures around this, and that we are able to then get closer to taking out that. The reason there's a brain icon here is that there is some command and control there, right? At some point, it is something that we can help take down. And we'll talk about this a little bit later. You don't even have to be that good to have a botnet anymore. It's like the laziest person can just go rent or buy one. And they have all flavors, right? They've got these access brokers who, may have purchased or been able to get in on vulnerabilities to get access. So they can be a mix of volumetric and targeted, or et cetera. But just the point here is, again, it comes back to money. So think about the motivation, think about how they're going to get you. And the reality is, if you're eating your veggies and doing and patching everything and doing your stuff, like, they shouldn't be getting into yours. They still may come at you from a offensive perspective, right? The second flavor here is proxies. And I think this is less well known. I think the differential in proxies that's worth noting is that they don't have to have gotten into your box, right? Like, these proxies exist and have plenty of, legitimate business purposes. They obfuscate traffic, and it's intentional. There are ways, but of course it's attractive to attackers. So, don't get a free VPN online. They are likely using that to pay for their business in another way. These are things that are allowing servers that route traffic to obfuscate the identity. Here's an example of a recent large-scale one. This happened started in 2021, but it's still happening. The Mirrors proxy attack, and these are request floods. This was on the MikroTik routers. Who here has a router in their home or office? Yeah. Who here knows who built it? Couple. These are things that are totally relatable in the sense that, so in this case, the attackers got in by creating a channel where they turned it into a proxy and taking advantage of that. But other proxies, including squids and socks, I was joking before we came on stage that I would say, these are not the squids you get at Legal Seafoods. They are a grosser one. But yeah, these are squid proxies. This is kind of a basic architecture of what this looks like in this flavor of grunge, as we say. So you've got your, bad actor who's then going through squid proxies to get to you. And the idea is that we are again, not talking about folks who actually have gotten in to run software. We are talking about them leveraging the inherent use case of a proxy, but just for malicious ends. And I think this is important because, sometimes folks attribute one to the other, but in fact, we should distinguish between those. All right, Paul is going to come give a story. It's not a bedtime story you will tell your kids, but it's a story.
That's true. All right, so we've had a very interesting time in the security field, right? We've, especially over the last 8 months, we've seen some things that have made us sweat, kept us up at night, and I'm referring to some of the recent 0 days that we've seen. So what I want to do now is propose a hypothetical situation where this happens, and the reason why I want to do that is because I want to give you insight into how we respond to it. I think that will be insightful for you. So my hypothetical 0 day that we're going to see today, tomorrow's hypothetical 0 day is Apache. Now, this is a super realistic example, not because Apache writes terrible software, but because it's so ubiquitously used. I mean, everybody's running these. I actually was curious about this. I went to go check on the internet. This link here will take you there. They have dominated the market, 60% of the market for 15 years since 1996. Can you just imagine how many of these web services are out there running this software?
Well, and we all know the open source ubiquity, right? I mean, these are just realistic 0 days to contemplate.
I never realized how valuable a backseat driver would be. So what happens on the day when this is disclosed, when this 0 day is disclosed? What happens? Of course, the internet wakes up. The first thing we see is scans across the internet, right? You might have been there. You're probably thinking back to those days when you saw this happening. Scans across the internet. Now, of course, we have that network of sensors I spoke about earlier, listening to these things, right? And these sensors are picking up all of these scans. And what's happening here is the bad actors are trying to find an instance or some machine running that's got this vulnerable software with this known issue that's just been disclosed, right? And so we are collecting every attempt to try and exploit that issue. So if you're sleeping right now, and I don't mean now in our session because you might be, but I mean in this hypothetical, if you are in bed and this thing gets disclosed,
no one is sleeping in our session.
AWS has already found these exploit attempts, and we're listening to the stuff while you're in your bed with your head drooling on the pillow. So what do we see? This is a real example of a type of exploit that we've picked up on our sensors. It's a set of commands that the bad actor's trying to run on your machine. And once this is run, they're golden, right? They're sitting there and they're smiling. Why are they smiling? Because these commands first get your machine to go and download a file, which is typically some generic binary that referred to as malware, as Merritt said, that allows them to control your server. Next, obviously, they give it all permissions, so anyone can run this file. And then they execute the file. And so once this has happened, even if you now go and patch, let's say Apache releases the actual patch to fix the issue, doesn't matter. It doesn't matter. They're already in. This can run there dormant for 1 hour.
Paul hit the ball a little bit here when he said they come in through our servers. We deliberately keep some unpatched servers to catch this stuff, right, which is kind of a cool thing also that we do on your behalf, just a side note.
No, exactly. This is our controlled network sensors allowing us to get insight into what your applications might be seeing, right? Because the whole internet space is being scanned by these things. So we get this intel. So what? What do we do? We see this interaction, this exploit attempt. What do we do for you? And we take a bunch of intel from this. This is just one interaction. We're getting thousands, millions of these things on our sensors. So we get suspicious source IPs, the IP that's sending us this exploit attempt. We get the signature of the exploit attempt. We get the IP that's hosting the malware, that binary file that the wget command is pointing us to. We get the actual malware itself, right? We go not through the wget, but our sensors are intelligent enough to identify this, go fetch it, bring it back, and analyze it. And then this leads us straight to where the brain is sitting, right? It's a treasure map for where the heart of the architecture that this bad actor is running. And so how do we protect you? What are we doing? First step, update managed firewall rules, right? Again, you could be sleeping. And if you're using our managed firewall rules, you're benefiting from a lot that all of this intel that we've collected, reputation lists get updated, threat signatures get updated, and immediately you're protecting yourself against ingress traffic and egress traffic if you're using network firewall. And thirdly, the next thing that we do is that Guard Duty obviously is a key partner of ours, right? So we run this network of sensors and we share this intel broadly internally so that all AWS services can help protect their customers. And most importantly here, I want to mention Guard Duty because we give them the actual binary file that we've seen from this zero-day exploit, and they then automatically update their signatures so you're benefiting from it. Now, sometimes, of course, bad actors get it right. Merritt pointed this earlier. All across the internet, instances are being compromised, including some of the AWS address space. And so in this case, we might only hear about this when a DDoS attack is started. So the command and control says, hey, target this IP. You're over here. You're being targeted. What do we see? We see traffic coming from outside of the border, and sometimes we see traffic coming from inside the border, which is in our backyard, and is really helpful for us because it helps us immediately kick in DDoS defenses. Right here we have standard defenses on the border, which is run by AWS Shield, rate limiting and blocking this traffic coming in, as well as automatic mechanisms inside to protect the availability of the endpoint that is being targeted. But we don't just stop there, right? We've got to help the innocent customer who owns those compromised instances. We've got to get them back to a place that's good for them. But we also further research these things. And so once you, this is where our internal intelligence strategy starts. This is where our threat intelligence strategy starts. Because it starts with what we see. We're able to see and what's going on to these in our backyard. Now, when I say, what do we see? I don't want you to start sweating there that we're looking at your data. We're not peering or looking into your packets. We're not violating any privacy here. I think you're sitting there going, hey, you're AWS, you're providing a service. You probably expect us to have some level of visibility. And for us, what the visibility that we find interesting.
I mean, we bill you for it, so you're not that surprised, I imagine.
Exactly. So, of course, you're running traffic internal between AZs in a region or cross-region or to and from the internet. You know, we provide you that differentiated billing because we record this net flow data. And so we use that net flow data in a very important way. We ask, remember now, what's in our mind, what's in our focus is those compromised instances that are in our backyard. So the question we're asking here is, who is controlling these compromised instances? Where is that C2 that sent that command to say, launch this DDoS attack? And so what that research reveals by taking these flow logs and going back in time, it helps us identify exactly who is controlling this botnet. Now, if it feels like we have a time machine, that's because we do. And this is an excellent way for us to use and leverage the hosting capacity that we've got in order to gather the threat intel that we need to protect you. And once we've identified the C2, we can go cut it out. Because what we've observed is that once you take that C2 out, traffic to everywhere, including AWS, just drops. And so day in and day out, we're holding up the shields, we're blocking you with reputation lists and block lists, but at the same time, we're working this other angle where we're trying to disrupt the botnets. Because every time we disrupt it, we drive up the cost for them to target AWS. And so once we know the C2, we've got a couple options, and it's time to take it down, right? Sometimes we just have an IP address, in which case we reach out to the provider or the person who's hosting that IP address, and we say, hey, here's the data, please investigate, take the necessary action. What we also do is we've seen botnets use domain names. In this case, the bots are registering with a domain name that's got many IPs on it. It's a great way for them to scale their architecture. We ask the domain registrars to deregister that domain. And you can see, we can see in our monitoring, DDoS attacks just drop. Ongoing DDoS is just falls away as soon as the C2 is taken out. So we work hard to do this and to take down this big architecture that's sitting behind the botnet. And so what we're trying to think about is how fast is our feedback loop? How quick can we go from learning about an architecture to putting in some protections for you? And we've done this by exploratory testing, right? We take all the data we've got. We know the C2. We know how the malware works. We've analyzed it. We've run it in a controlled format. And we can actually understand the attack commands. So now the C2s are saying, hey, we're about to go target this IP address. That gives us the front foot to act really quickly. In this case, the C2 commands are pretty straight. They're pretty common. I mean, they've got the vector, the destination, IP, and port. They've got some parameters that they throw in that the malware is expecting. But we are decrypting these. We're understanding how C2s are communicating. And while we're taking them down, we're also monitoring them so that we can be, as I said, on the front foot to acting quickly. Now, I want to quickly share with you some data that we've got. Obviously, we're doing this at a greater scale than just these 5 commands. And what we're observing is that this is a very busy graph. But what this is showing you is the C2s that we're receiving commands from by ISP, right? You might notice that AWS is not on the list. We actually are on the list. We're not perfect. We're just pretty far down. And I think that's a big testament to the work that we're taking and internally looking at what's happening on our network and taking down these bad resources. And then next, this is a different cut of the same data. Who is being targeted? Who are the victims of these C2 commands? By ISP, right? Of course, AWS is on there. I think we're 6th. We're 6th on the list. And in this situation, we have a C2 saying, I'm about to attack this IP address. We're golden. We understand exactly what this botnet is trying to do. And so, yeah, I wanted to share that with you because I think you'd find this interesting and that you understand what we're doing in the background to get behind and disrupt these threats that are sending DDoS traffic at layer 7. Merit.
Awesome. I love this stuff. It just makes me feel cozy. I don't know about you all. So I think the point is, one, we work really hard in this, right? We get better over time. We put in the hard work. We accumulate the indicators. But also we have the muscle groups. So the point isn't about getting one indicator. It's about having the mechanisms by which we can make sure that we get them time after time. And I think part of this is the way that, Paul and other folks from his team approach it. Part of the way is that we at Amazon approach it, which is that we solve big problems by solving small problems, and we accrete over time. And it's kind of like layers of sand. But ultimately, as I have mentioned, you are so better off knowing that we are working on a lot of this stuff that we've mentioned on your behalf, which you inherit without paying anything extra. And then now I want to talk about what you can do on your behalf, right? I would be remiss, as someone who talks to CISOs a lot, like, there are things you can also architect for on your side that I hope you will take back and think about and figure out what makes sense. So we've got tons of tools in the arsenal, right? We've got a lot of just platform layer things like Route 53 and, you know, the ways that you will access internet and CloudFront and CDNs and everything. But you will also leverage things like Guard Duty that we mentioned that have indicators. You will leverage things like WAF and Shield Advanced and Network Firewall and Managed Rule Sets. Here's a white paper if you would like our current guidance around DDoS resiliency best practices. This is one to Takedown. This is trying to, you know, reduce your own likelihood by, you know, obfuscating resources using ALBs. Application load balancers, sorry, I should have. There are 3 flavors of managed rules right now. One is baseline, which are like common stuff that we see, and sort of general protection. One are case specific. So these are incremental protection against use cases like SQL, PHP, operating systems, etc. And then the last is an IP reputation list, which we've talked about a little bit in practice. But this is where we actually take the intelligence that we see as Amazon.com and you know, do it based on source IP. This is just an example of some of the kind of like sprinkles on the cupcake that you can vend yourself as a customer. We're obviously building this on top of all the infrastructural protections that we've talked about, but this is one that is particular to bots. Since we mentioned bots today, you can vend a rule set against bots that's called WAF Bot Control. And then similarly, we see Route 53 Resolver DNS Firewall. So this is, you know, it's a managed service and it's free. And this will help you protect against commoditized things. So ransomware from known groups, for example. And, you know, this is something that really allows you to avail yourself of these managed services free. I mean, like, nothing is better than the service you don't have to manage. And in pretty much all of my talks, I include my rescue pug, Peanut Butter. Every time that I give her a bath, she like gets in her bed and does this weird roll around. So this is a picture I captured. But the point is, this is not a static thing. You will want to rinse and repeat, you know, figure out what makes sense for your resources at any given time, continue to update, continue to reevaluate, and continue to make sure that your shop is also growing up with what you consider to be your most important, your most protected, and also what your internet facing stuff is, which of course is kind of an inherent value proposition of cloud that you can have a lot of knowability there. So we are wrapping up now. I know, you're very sad. I am too. Everything has to come to an end sometime. But we want to revisit these questions that we hoped that you will note. We hope that we have helped to answer these for you. So in particular, are you doing, like, ask your providers this. They should be able to look you in the eye and give you an answer. And if they can't, then that should tell you something. Are you doing more than, you know, shields up a wall of defenses? Are you doing proactive defense mechanisms? How much do you know? Like, what are you using from your insights to better protect me? And then what is on your side, right? How can you protect yourself? How do you know it's working? How can you metric this? Thank you so much.